Let's take a look at another example to continue practicing these ideas. In example 3, we have the following scenario. Suppose that an airplane is flying in a straight direction at a constant height of 5 kilometers. Now I'm going to let the angle of elevation of the airplane from a fixed point of observation be called theta. And then the speed of the airplane is 500 kilometers per hour. And our question is, what is the rate of change of the angle at the moment when it's 45 degrees? Oh boy. Okay, so let's try to break this down and slowly start to construct our moving picture. All right, I'm going to deal here with this first idea that an airplane is flying in a straight direction at a constant height of 5 kilometers. So I'm going to go ahead here and state maybe my airplane is right up here. Now technically I guess I should draw my airplane here in a blue dot because it is going to be moving. Now for the sake of argument, let's suppose that our airplane is actually going to be moving to the right. Okay, so it's going to be going off the screen this way. Now, if this is my airplane and it's at a constant height of 5 kilometers, then I know that this value here should actually be 5. Now I'm writing that in black and not in blue because notice that if it was in blue, that would mean that it would be changing. And I know that the height here is not changing. It's at a constant height of 5. So a black value here means that it's locked in. Now we have to deal with this next sentence, which talks about an angle of elevation. So let's suppose that this fixed point of observation is maybe like right over here. Okay? And so you could see that from here on the ground, I could go ahead and I could like look up and see the airplane, right? I could look at it. This would be like my line of sight. Now the angle of elevation of an individual or from a point of observation is always the following. You have to imagine from the person's eyesight that there's kind of a horizontal line that a person could always look out in. But if they have to go and look up at an object that's floating up here, this person is going to have to kind of tilt their head upward, right? They're going to have to tilt their eyes upward to view this. And there's some angle that they have to tilt their eyes upward in order to actually see the object. And how much they actually rotate their head is our angle of elevation of theta. So if I imagine that a person is standing right here, and this horizontal line is where they would normally be looking, then this angle right here is going to be my angle of elevation theta, because that's how much they had to tilt their head up to see the airplane. So that's what we mean when we talk about angle of elevation. Now, if I go ahead and continue reading here, I can see that the speed of the airplane is 500 kilometers per hour. Now, I'm not entirely sure where to put this in the picture, but let's go ahead and at least note a couple other quick things in this scenario. Let's quickly see this. If my airplane, again, is flying in this particular direction, then is the person that's standing here going to have to continue to tilt their head higher and higher and higher, or lower and lower and lower? What would allow them to continue to see the airplane? You know, imagine the airplane is now moved over here and then over there. Well, yeah, you could probably see that this angle here is going to have to be going downward. And there is a speed at which it's decreasing. In fact, that's what we're trying to find. But it's important to note that the angle is decreasing. It's going to have to be going down to view these other dots representing the airplane as it flies out to the right. Now the other thing that I could note is going to be changing here is that if the airplane continues to fly out to the right, isn't the distance from this point to being right under the airplane, isn't that going to be changing? Sure. Now let's suppose that I call this distance in here that's going to be changing. Let's suppose that I call this distance x. And again, I know that this distance here is increasing. It's moving in this direction. But if the airplane is flying at a speed of 500 kilometers per hour, then I could actually state that this side length is growing at a rate of 500 kilometers per hour. So this is kind of my moving picture, right? I can see all the pieces that are moving here. I can also state very, very clearly that actually this side right here would also be considered a moving side because its length would constantly be changing. And so I'll redraw that in using some blue as well. Now, if I wanted to go ahead and summarize all of this again in the stopped picture, I'd still have my person down here. I'd still have my value of 5. My airplane now would be completely stopped. my value of x would be locked in at some specific value. This side would no longer be growing, and my angle would be locked in at a particular amount. So let's take a look here at what's happening in the stopped picture. When is it that I'm told that I'm going to pause the movie? I'm going to keep letting this angle go lower and lower and lower, and then I'm going to pause the movie at the moment when theta is 45 degrees. Okay, now there's probably a lot of things I could figure out here about this picture, but I'm going to hold off on doing that right now. I'm going to focus on setting up step 1 and step 2, and then I'll see what information I'm going to need from my stopped picture to calculate step 3. Let's go ahead and start with step 1. Well, I'm going to need here the ability to relate together the variables of theta and x, as those are the only variables that I have here in my picture. So in this scenario, something like the Pythagorean theorem really won't be useful because I won't be able to account for this angle of theta. This is a great time to think about using some trigonometry. In fact, we talked about some questions on the recent skills check that would allow us to actually set up some nice trig ratios that represent or that relate the different information that we have here in the triangle. Notice we have an angle theta, a side of x, and a side of 5. You might be able to tell that one formula that I could use here would be tangent of theta is equal to 5 over x. This would work out beautifully. Now, if I wanted to go to step 2, I would have to go ahead and take derivatives of both sides of this equation with respect to the variable of t. So I'll take the derivative of the tangent of theta, and then on this side, I'm going to be taking the derivative of, notice I could rewrite that side as 5 times x to the negative first power. So let's see what happens as I take the derivative here. The derivative of the tangent of stuff is always going to be secant squared of stuff. But then I have to follow up with the chain rule. The derivative of theta is really just going to be d theta dt. Now that's good that that's popping up in here because that's really what I need in order to answer the question, right? That's what I'm looking for. Over here, notice I'm going to get negative 5 stuff to the negative 2 using my power rule, and then chain rule do the derivative of the stuff. So this is what I have here for my derivative. And now I'm going to be interested in trying to go to step number 3 and evaluate each of these different pieces. So let's see what we're going to end up with here. For step number 3, I'm going to need to be able to find what dx dt is. Boom, have that, that's 500. I'm going to need to be able to find what x is, so I'm going to need to figure that out in the picture. And I'm also going to need to know what the secant of my angle theta is going to be. All right, so let's see what we have here. For step number 3, I can realize that I'm interested in the secant squared of 45 degrees. I'm going to need to figure out what this value of x is, and I already know that dx dt is equal to 500. So let's just focus on this value of x. It seems like that's the only thing I need in this picture. And actually, I think it's going to be unbelievably easy to find. Notice that if this angle here in the triangle is 45 degrees, and I have a nice right triangle, then my other angle in this corner is 45 degrees. Now that means I have an isosceles triangle, which means that the sides across from those 45-degree angles have to have the same length. So I can kind of very, very quickly find that this side here is also going to be 5. Now, I can go ahead and start to compute some things with this. I can see here that the secant of 45 degrees, I should be able to calculate that as the square root of 2, and notice I am going to need to square that, since I do have secant squared. On the other side here, notice I'm going to get minus 5. This is going to be over 5 squared, or over 25, and then times 500. So over here I'm going to end up with 2 d theta dt, and I'm going to have negative 1/5 times 500. Notice that side's going to then turn into just negative 100, and when I divide by the value of 2, I'm going to end up with negative 50. Now I have to put some units on this, and this is the hardest part, at least for this question. The value of t is easy because I can see throughout the entire problem I've been measuring the value of time in hours. I can also then see that if I want to measure or find the units for the top, I have to think about the units of theta. And here's where I have to be a little bit careful. While theta in this question was given in degrees, degrees are not going to be what I'm allowed to put here. Because notice that in this question, I had to take the derivative of a trig function. And that means, if you might recall from back when we developed the trig derivatives, is that this requires that our angle be expressed in radians. Now, that's actually not a problem, because if I wanted to go down here, I could have rewritten 45 degrees as pi over 4. But what it means is that in here, my value of theta typically is thought of in radians. It actually must be thought of in radians. And so what I'm actually going to have here is something like negative 50 radians per hour. Now you might be thinking here, wait a minute, why is this negative? How does that make any sense? How could my speed of my angle be negative? And really what the negative here corresponds to is that my angle is decreasing, right? It's getting smaller. So my angle is shrinking at a speed of 50 radians per hour.